Okay, so I'll be giving you few structures which you have to name, and I'll give you the bond line structure, the zigzag structure.
Yes, sir.
You can start solving them one by one.
Yes, sir.
And it's always better if you even draw it in your notebook.
Yes, sir. So is it BR or just B?
BR.
Yeah.
So let me know when you are done doing all of them. Okay, I've just marked it. You can move ahead and then I'll address all your doubts together.
Okay, sir.
Okay, so tell me the first one. What is the name of this compound?
2,2 dimethyl pentane.
2,2 dimethyl pentane. Correct. So the numbering will start from this side, right? This is how you must have numbered it. Okay. So at position 2, there are 2 methyl groups. Okay. Go ahead. Next. Second one.
2,3 dimethyl pentane.
Okay. So same thing here. One is at second position and second is at third position. So 2,3 dimethyl pentane. So both are dimethyl pentane, but the positions are different. Yes, the third one.
Third one is 3 bromo. No, 1 second. Yeah, 3 bromo, 2 chloropentane.
It is 3 bromo because 1, 2, 3, 4, 5. This is how you will number it. So 3 bromo, then dash, right?
2 chloro. Yeah, dash 2 chloro dash. 2 dash chloropentane.
2 chloro pentane. Correct. Okay. What about the fourth one?
Fourth one, 3 ethyl hexane.
3 ethyl hexane. That's correct. Because the longest chain is this.
Yeah.
Right. So at the third position, this is the substituent, which is ethyl. Good. So this is 3 ethyl hexane. Good. Sixth one.
2 chloro. Fifth one is up. So 2 chloro. 4 methyl. Yeah, hexane. 2 chloro, 4 methyl hexane.
2 chloro, 4 methyl hexane. Correct.
Sixth one, 1,3 trimethyl cyclohexane.
Okay. So this is position 1, this is position 3. On 1 there is methyl, and on third as well there is methyl. So that's why the name is trimethyl.
Yes.
Right. So this is, as you said, 1,1,3 trimethyl. Next.
Trimethyl cyclohexane.
Correct. Cyclohexane, because it is a cyclic compound. Okay, so that's
Yes.
correct. Let's move to the next one.
I wrote 4 ethyl. 4 ethyl. 1 second. Yeah, 4 ethyl, 2 methyl, 1 propyl cyclohexane.
That's correct. So the numbering has to start from here.
Yeah.
Right? So we have to number in such a way that if I do like this, the positions are 1, 2, and 4. That's why this is, or this, only this will be the scheme where you will have the lowest numbers. So this is propyl, this is methyl, and this is ethyl. Now, while writing, you have to write in alphabetical order.
Yes.
So that's why 4 ethyl. After that comes
Alphabetical
methyl.
order.
So 2 methyl. After that comes propyl. So 1 propyl. Cyclohexane. Yes, so that is correct. So you had some doubt here, right?
I kind of figured it out from the previous question. So what I wrote is 1 ethyl, 1 methyl, 3 propyl. No, one ethyl, 3 propyl, 1 methyl. No, one second. EMP, yeah. 1 ethyl, 1 methyl, 3 propyl, cyclopentane.
Correct.
Yeah.
So
Alphabetical order.
yeah, that is correct. So this is 1 ethyl. So at position 1, there is ethyl. See, we have to write in, while writing, you will always have to write the substituents in alphabetical order. So at position 3, there is propyl. At position 1, there is methyl and ethyl both. So first you will have to write ethyl. Then at the same position 1, there is methyl. And then you have propyl at third position, so propyl and cyclopentane. That is correct. Next one.
9th one is 2 bromo 4 chloropentane.
2 bromo 4 chloropentane. Yes. So you can give them numbers. If you start giving them numbers in this way,
So, yeah.
this is wrong.
It will be wrong.
Right? Because if you see both in both the ways, yeah, in both the ways you will get 2 and 4. If you start giving them numbers in opposite direction, right? 1, 2, 3, 4. So both in both the scheme, the substituents are at position 2 and 4. So you have to break the tie. So the lowest number should be given 2. Now, because everything is same, when everything is same and then you have to break the tie, then you have to go with the alphabetical order. So the green one is the right scheme, right? Because bromo, B comes first, chloro, C comes next. So its name will be, as you said, 2 bromo.
2 bromo 4 chloropentane.
Right. Okay. Coming to the next one. Here you can see there is methyl and here there is ethyl. Yeah, go ahead.
Ethyl. 1 ethyl, 2 methyl, cyclohexane.
Exactly. So this is 9th and 10th are similar. They actually address the same
even 11th is a
situation. Yes, even 11th. So in 11th also, the bromo will take position 1 and chloro will take position.
Chloro will take 2, yeah.
Right. So I think you can name it. So I'll move to the next category of questions. So these examples were having only simple substituents.
Substituent groups.
Now you may also have complex substituents. Complex substituents means, for example, suppose if a substituent is like this, suppose this is the main chain, right? This is the main chain and this is the substituent. So here it's a simple chain. It's a simple single chain. So this is a simple substituent, right? Where there are 3 carbons, and that's why this will be called a propyl group, right? What will happen if there is a branching in substituent? So complex substituent is nothing but substituent with branching, right? So in that you don't have to worry much. Even that branch or that substituent which has branches, they will have to be named as per IUPAC system. As you will name any alkane with branches, how do you name them? The same technique has to be used with the substituents as well, who themselves have branches. And in that case, only one difference is what? Instead of alkane in the end, you will have to write alkyl. Only that will be the difference. So to practice this, let me give you a big molecule which has the substituents. First, I'll ask you to identify those substituents, right? Whether they are simple or complex. And then if they are, whether they are simple and complex, that is the first thing which you have to do. And then next step is to name only the substituents. Only the substituents, right?
Yes, sir.
So I'll give them numbers or symbols. Let's say this is A, B, C, and D. So which one do you think is simple and which one is complex?
The A is simple, B is simple. Yeah, A and B are simple.
And others are complex. Okay, now name this group and this group, the simple groups.
Yeah,
We'll
for
finish.
A is ethyl, no, propyl, and B is one, two, three, four, butyl.
Correct. Okay, so the simples are over. Now let's come to the next one, that is this C.
Yes, sir. C is uh, one second. So here it is attached to the second carbon of the butyl group. One second, actually, one second. Two methyl butyl.
C or D? Which one you are
C.
solving? C or D?
C, C,
C.
C.
See, I'll tell you the rule or I'll tell you the trick which you have to follow here. See, you have to identify the longest chain starting from the carbon which is directly attached to the ring or to the main chain. So
Yeah.
one thing is for sure that the cyclohexane is the main chain.
Yeah.
Right? Now, which is the carbon which is directly attached to the main chain or the ring? This carbon,
Yeah.
right? And from there, you have to start and find the longest chain. If you go to the left, you have only one more carbon. If you go to this direction, there are two more carbons. So obviously, this is the longest chain,
Yeah.
right? And then the carbon which is directly attached to the ring or the main chain, that has to be given position 1.
So will it be one methyl butyl?
Correct. It will be
Because
1 methyl.
what I was thinking that okay, yeah, because what I got confused was that if I put one, then it will rather be a straight chain than a branched, right? So you
Yeah.
can make it as a
There was one more mistake. It will not be butyl. It will
butyl
be
propyl,
propyl.
right? Yeah.
Okay. Now can you name the
C,
substituent B?
yeah. Yeah. So it says 2,2 dimethyl propyl.
Correct. This is 2,2 dimethyl propyl, right?
Yeah.
Correct. So this is how you have to first identify. This was just a practice to identify simple and complex substituents and how to name them. Now, let me give you one more structure having such complex and simple substituents. Yes. Let's say this is A, B, C, D, E, and F. I think one thing is very clear that all of them, all these substituents are complex one. None of them are simple one.
Yes, sir. A is A is 2-methyl propyl.
Is 2-methyl propyl, correct?
B is 2-methyl. No. 1 second. B is 1-methyl propyl.
Correct.
C is 1-methyl ethyl.
Okay.
D is 2,2 2,2 dimethyl ethyl.
2, 2, or 1, 1.
Sorry, 1,1. Sorry, 1,1.
1, 1 dimethyl
Ethyl.
ethyl, correct. Next,
E is 2,2 2,2 dimethyl propyl.
okay. Last one.
F is 1-methyl 1,2 dimethyl propyl.
Okay, so that's all. I think now you know how to identify these complex substituents, right? And
Yes.
how to name them. Now, whether they are attached to a cyclic this thing, to a cyclic chain or to an open chain, the naming of the complex substituent will be same.
Yes.
Okay, it doesn't matter whether it is attached to a main chain, which
Alpha
is,
or
yes. Okay, and while writing you always have to write, I mean, if if there is the complete, while writing the name of the complete compound, you have to take care that you have to write it in a lexicographical order, or the order in which these names will come in a dictionary, right? Alphabetical order. Okay. So let me give you a compound. Yes. Now let me ask few questions before you actually start writing the name of this. First question is, which one is the main chain? Right? Main chain or main ring. Is it the cyclopropane? Right? Because you can see there are 3 carbons in this chain. Or is it this butane?
Cyclopropane.
Cyclopropane. Reason?
Because it's a closed structure.
Because it is a closed structure. Okay. See, so this is something which you should be clear about. It's never the cyclic versus open chain. There is nothing like this, that a closed structure has to be given more preference over the open structure. It's not the case, right? This thing is not valid, right?
Okay.
Right, so that is the reason. That is one thing which you should understand. Now, still in this case, cyclopropane is the structure which will be the main chain, or which will be the main ring, right? And the reason for this is the priorities which we have fixed. The main chain, when you have to select the main chain, there are few things you should consider. First, and not in order actually. First thing is, or the main chain, the definition of main chain is, it is the longest chain with maximum number of substituents or multiple bonds or functional group, right? So
Okay.
all these things are important. Longest chain
Number of substituents.
with maximum substituents or functional groups or multiple bonds. So now in this case, and obviously out of these, highest priority is given to functional groups.
Functional groups.
Then comes multiple bonds.
Multiple bonds.
Then we have substituents. Right? So priority, even in this, priority is this. So you can see here, there are no functional groups, there are no multiple bonds. So what is left? Only substituents in this case. Now, if I take ring, in this ring, I have 1, 2, 3 substituents.
Yeah.
If I take the butane, although it has more number of carbon atoms, ring is 3 carbon.
Only one substituent.
And butane is 4 carbon, yes, but it has only 1 substituent. So that's why, which one will you choose? You will still choose the longest chain as the ring. So that ring will be the main chain. So now if you see, there are 3 substituents. So this cyclopropane is the main chain, and there are 3 substituents, A, B, and C. Out of that, A and B are
Methyl.
methyl.
Normal. Yeah.
Yes,
Simple.
simple. But C is the complex one. Now you
Complex
have
one.
to name the entire compound. So while naming, you can give it a try. Then I'll see if
Yeah.
it requires an explanation or not.
Yeah. 1, 2 dimethyl 3 3 in brackets 1 methyl propyl cyclohexane. Cyclopropane.
Cyclopropane, yes. Yeah, that is the correct name. Okay, so I hope now you understood this as well. So let me give you 2 more examples for this. Or a few more.
Mm.
First and second are simple, so don't get confused there.
Yeah. First is 1,4 dimethyl cyclohexane. Second is 1,2 dimethyl cyclohexane. And third one is 1,4 in then dash in bracket 2,2 dimethyl ethyl cyclohexane.
Can you repeat the third one?
Third one will be 1,4 in the bracket 2,2 one second 1 2 3 2,2 dimethyl ethyl, then close the bracket cyclohexane.
Okay, few points here. First thing is, see, wherever you write 1,4, 1,2, so see, you're writing, that means that if I write 1,1,4, so that means there are 3 repetitions. So there will be try. If I write 1,4, there will be 2 repetitions and there will be die. If I write 1,2, 3, 4, there will be 4 repetitions and that means there will be tetra. So that's why we use di, tri, tetra and all here.
Bis.
Correct. So here, when the complex things are repeated, we have to use, because die we are using
Bis.
for simple. So when
Yeah.
the entire complex substituent is repeated, we have to use bis. For 2,
Yes, sir.
bis. For 3, tris. For 4, tetrakis, etc. That is the first thing. Second, we have already practiced this, naming the complex substituent, that you have done wrong again. If you see, this is the first carbon, this is the second carbon. So this will be 1, 1 di
Oh,
ethyl
yeah. One. Yeah.
ethyl. Right? So complete name will be
Yeah.
1, 4 bis,
Bis.
and then
1,1 dimethyl ethyl cyclohexane.
right. So now I think the second one you can name it easily, right? 1, 2, or you can name it.
Yeah.
Yes. So that was about
1,2 bis. 1,1 dimethyl cyclohexane.
correct. Okay. So that was about the IUPAC of compounds containing both simple as well as complex substituents.
Yes, sir.
Right. In our next session, we will cover compounds with multiple bonds and functional groups as well.
Okay.
Okay, so that we'll do in our next session.
Yes, sir.